Okay, let's get started. Today we will be covering section 6.5, variation. I may be going a little more quickly than usual. Please keep in mind that with this video recording, you have the option of stopping and replaying as needed. Today we will be covering three types of variation: direct variation, inverse variation, and joint variation. As you will read, a variation equation is an equation that relates one variable to one or more other variables through the operations of multiplication or division, only using multiplication and division today, or both operations. In direct variation, that's the first type we'll talk about. You see we have three, and that's the first one. Direct variation, the values of the two related variables increase or decrease together. Okay, so the two related variables increase or decrease together. The most common equation that you have worked with is probably distance is equal to rate times time. Rate is the constant. Let's assume you're driving at a constant rate, say 60 miles per hour. As you work with this, if you increase the time, you increase the distance. If you decrease the time, you decrease the distance traveled. So you can see that these two related variables, that would be the distance and the time, increase or decrease together. As one increases, so does the other. As one decreases, so does the other. If a variable y varies directly with another variable, so anytime we have this situation, we can express it in this form: y equals kx. K is this constant. In the example that I used earlier, k was the constant speed of 60 miles per hour. All of these problems will have a constant. We call that the constant of proportionality, or the variation constant. We'll be saying constant of proportionality most of the time. So when you work these problems, you can follow this basic procedure. First, you can write your equation with variables. And this will be in the form y is equal to kx. K will stay k in all of these. The y and the x, you may want to change those depending on what you're representing so that the letters make more sense. The second thing you'll do is you'll substitute in initial values of x and y, or whatever your variables are, and solve for k. Find out what the k is for that particular situation. And finally, you're going to go back to the equation, rewrite y equals kx with the actual number value in for x. I'm sorry, in for k. And then we're going to substitute for the fourth step, substitute and solve as indicated. Okay, this will make more sense, these four steps, as we work through the first example. Again, if that's too quick, go stop and back up. The property tax T on a home is directly proportional. So on the test, the questions will all be mixed up, but when you see the word proportional, you'll know it's something from section 6.5 on variation. Directly proportional tells you that you'll be using an equation of this form, where they're directly equal with a constant of proportionality here. So we have property tax T is, remember that is our equal sign, directly proportional. That tells us we need this constant of proportionality, K, to the assessed value. So the tax is a proportion of the value. It might be 10%, whatever. It's a certain fixed constant. If the property, so we've done the first step, we've written our equation with the variables that were given in a k. Second step is to substitute the initial values. It says that if the property tax on a home with an assessed value of this is this, so that's the actual tax, so I'm going to scribble tax in there. So I'm going to go down here and I'm going to put the tax is $2,100 if the home is $140,000. then this is the last part that we're going to look at in a second. Now that has given us enough information to determine what K is. K will be, we divide both sides by 140,000, so we'll have 2,100 divided by 140,000, and we'll get that the K is equal to, write it as a percent, 1.5%. You're going to get that as a decimal. Actually, we probably could just use it as a decimal. K is going to be equal to 0.015. If you only needed K, you might need to write it as a percent, but we'll go ahead and leave it in its decimal form. So this is what we need. We've completed step 2 now. We've actually figured out the value of K. The third step is to rewrite the initial equation and to put the value of K in. So rewrite the equation and put in the value of K. So I take my initial equation. T is equal to K, but the actual value of K is 0.015 times V. All right, and so now we solve for whatever they tell us. What is the property tax? So we're going to be looking for tax, T, on a home with the assessed value of 180,000. So that's my value. So I'm looking for T. We're doing the last step now. And I put in 180,000. And I get that T is equal to $2,700. And so we've completely solved this equation following those steps. We'll be using those steps over and again. We're ready for the next example. Number 2. Distance. The distance d that a rock falls when dropped from a cliff varies directly as the square of time the rock is falling. If a rock falls 64 feet in 2 seconds, how far will it fall in 3 seconds? Same procedure. We begin with our equation. Distance varies directly equal to, with a constant of proportionality, the square of time. So we don't just put time, but we put time squared, the square of time. If a rock falls 64 feet, that's the distance. We're looking for the K in 2 seconds, so we have to take 2 and square it. All right, order of operation dictates that we have to square 2 first. 2 times 2 is 4, so we'll have 4K equals 64. Divide both sides by 4, and you will get that the constant is 16. Now the question, the second part, and we could kind of block that off each time to be consistent. Go back to your original equation and replace the K with the actual constant, which is 16. And we put in how far will it fall. We're looking for D when the time is 3 seconds. So this time I take 3 squared. Okay, 3 squared is 9, right? I have to do that first. And 9 times 16 gives me 144 feet. There we go. We're done again. Same steps again. You will have probably 2 different types of questions from this section on your test. One will be direct, probably variation, and then one of the inverse or joint that we'll be doing in a minute. Okay, moving on to the next example. I think I'll fold this paper so that it's easy to flip up to the top. Profit. The profit P from selling lawnmowers is directly proportional to N, the number of lawnmowers sold. If the profit from selling 8 mowers is this much, here's the last part, determine the profit from selling 15. Same procedure. We start profit is directly proportional, put in your K, to the number of lawnmowers, put an N in. If the profit, so that's my profit, from selling 8 lawnmowers, so the number of mowers is 8, and the profit is 600. Okay, then I divide both sides by 8, and I'm skipping a little algebra here, so do what you're needing to do, and you will get 75. Okay, that's my constant. So then I take the original equation and I rewrite it with the actual constant for this situation. And now I determined the profit, so I'm looking for P, from selling 15 lawnmowers. Okay, the profit will be, don't forget to put your dollar sign, you'll need the units on your answer, 1,125. Very well. Okay, not everything is direct variation. We need to move to the next situation, and that is called inverse variation. I kind of wish I had a heading here. Inverse variation. When two quantities vary inversely, as one quantity increases, the other one decreases, and vice versa. Also referred to as inverse proportionality. You'll hear it called that. So you can think of some situations here. The amount of time needed to cook something. If you increase the temperature, you will decrease the time. If you decrease the temperature, it will take longer, more time. So as you increase one, you have to decrease the other, or the other way around. If a variable varies inversely, we write it like this. Okay, so this is going to be the starting point equation. When you see that varies inversely, you'll use this, whereas with directly, we use the other equation. K is again the constant of proportionality. So let's try a couple of these, see how they work. It's pretty much the same thing, with just written in a different form fraction. Melting of an ice cube. The time t for an ice cube to melt is inversely proportional. So on the test, that would be your cue word of which way to set it up. Remember, you may want to put both of those on your note card and label them so you'll know which one to choose. To the temperature T. So the time is inversely, that means I get a constant of proportionality. Inversely means I put it in the denominator, the temperature. Now notice I have a little t and a big T here, which is a little confusing, but it'll be okay. All right, if it takes an ice cube 2 minutes to melt at 75 degrees Fahrenheit, here comes the second part. How long will it take this ice cube to melt in 80 degree water? So we take the first set of numbers and put it into this first equation to find the K, just like before. It takes an ice cube 2 minutes. Little t was time. To melt in a temperature of 75 degree water. Okay, remember what we did here in class the other day was we said we could cross multiply, or we could multiply both sides by the common denominator of 75. That's the way I'm going to do it. This pen isn't working terribly well. Okay, so I take 2 times 75 is 150. Here I have 75 divided by 75, which makes a 1, so we just have the K as 150. We take the original equation just like before, and we rewrite it, and we put the K value of 150 in, and there you go. Now we take the part in the box and we do the second part. How long, so we're looking for time, will it take an ice cube to melt in 80 degree water? So we put 80 in for the temperature, and that's going to give us 1.875 minutes. If I had a calculator, I would double check that. Let me see. Have any calculators handy? Let's take 150 divided by 80. Double check that value. 1.875 it is. Yes, very well. Good. All right, the final example on this page, number 5, speaker loudness. The loudness of a speaker I is measured in decibels. It is inversely proportional, there we go again, it tells us what kind of problem it is, to the square of the distance d of the listener from the speaker. So the loudness is inversely proportional, some constant, times the square of the distance to the listener. Oops, I put that directly, didn't I? We need to write this inversely. I is equal to, inversely means we have to put it in the denominator. Very well. Okay. Now we have the first part. If the loudness is 20 when the speaker is 6 feet, and that will be the second part right there. Okay. If the loudness is 20 decibels, so we put 20 right here. Okay, over the distance is 6 squared. Okay, so that's going to be, we're going to multiply both sides by 36, right? And that should give us 720 as the constant. Now we take this same equation and we rewrite it with the actual constant that we have for this situation. 720 divided by the distance squared. So here they say, what is loudness? We're looking for the I. When the listener is 3 feet, that's the distance. So I put 720 over 3 squared. And I'm believing that's going to give me 80 decibels. That looks good. Okay. Very well. And the final situation, I said there were 3 types of variation. This is joint variation, where we have more than one thing going on. And this is a more complicated situation, but it's not hard mathematically for us to work. This is called joint variation. The third type. The general form of joint variation, where y varies directly as 2 things, x and z, you would write it like this. So on these, it could be directly and inversely. Several things are going on, more than one. K is again the constant, and the steps are just the same, just has a little more going on. Okay, so let's work this first one. The wattage rating. The wattage rating of an appliance varies jointly as the square of the current, I, and the resistance. Okay, so there's my first part. I'm going to block that off. If the wattage is this when the current is that and the resistance is this, there's the second part. And here comes the last part. So the second part I didn't block off, and there's the last part. So we have 3 parts to this equation, right? Or to this problem. Okay, the first part, we write our equation. The wattage varies jointly. That means we need a constant of proportionality as the jointly as it doesn't say anything about being inverse, so we just go ahead with directly related here. The square of the current, now that's kind of weird, an I squared, and the resistance R. Remember, these are always multiplied. We don't ever add or subtract. We always multiply or divide. Okay, now we take the second sentence and we put this set of numbers in to solve and find K. If the wattage is 6, that goes here. When the current is 0.2 amperes, so that's this I was the current, 0.2 amperes, and that has to get squared, right? I'll put a squared outside. It doesn't really matter. And then we're going to multiply by the resistance, and it tells us that 150 ohms is the resistance. So I put that in there. All right, so I'm going to work this out. I don't actually have my calculator with me at this moment, but when you work it out, of all things, you're going to get K is equal to 1. Okay. Now rewrite your equation. K is 1. You can write that in there if you want so that you don't think you've forgotten something. It's not necessary to write it if you'd like to leave it out. And now we determine the wattage. We're looking for W. When the current is 0.3 and the resistance is 100. Okay. 0.3 squared multiplied by 100 is going to give us 9. Now 9 is the wattage and we need units. So let's look up here and see what they told us about wattage. Wattage is given in watts. Yeah, that makes sense. So we're going to leave that as 9 watts. Very well. Moving on to our final page. Often in real-life situations, one variable varies as a combination of variables. It's sometimes called combined variation. And here we go with another one. The electrical resistance of a wire T varies directly as the length and inversely as the cross-sectional area A. So we have two different things going on here. Let's just go ahead and write that. The resistance T is going to vary. That when it says varies directly, I have to put my constant in. Varies directly as the length. The word varies is what gives us the constant actually. And inversely, that means this part has to go in the denominator, as the cross-sectional area A. Okay, that's weird, but that's it. So we're now ready to take the next sentence, which is going to have a set of values up to this comma, and then they're giving us the what is. That's the third part, right? Okay. If the resistance of the wire is that, so that's going to go in for the resistance, 0.2. When the length is 200, so that's going to go right here for the length. We divide by A, which is a cross-sectional area. The cross-sectional area is 0.05, and you're going to solve that, and K is going to work out to be 0.00005. So what I do is multiply by 0.05 on both sides, and then divide off the 200, and you should get this for your K. Now you take the initial equation and you rewrite it with your constant 0.00005 times L all over A. And we do the actual solution to the question here. What is the resistance? We're looking for T of a wire whose length is 5,000. I'm going to put a 5,000 in here, with a cross-sectional area of, the area goes in the denominator, and I'm not writing my units, it's not necessary, and we should get, do I have the right number of zeros? Yes, we should get 25 ohms. And 25 is the resistance, so you would look back up here and it says the resistance is that many OHM, so that would need to be the unit that we put here on this. Very well, we have only one more and we will be done with this. Nice and quick section. The number of vibrations per second, V, of a guitar string varies directly as the square root of the tension and inversely as the length of the string. There will probably be one on the test that has this situation where two things are going on. If the number of vibrations per second is this, okay, here goes this question, go to the comma, and then the last part is to determine la-di-da. Okay, we're ready to go. The variation of a string varies directly as the square root of the tension. So the tension is T, and it's supposed to be the square root of T. So we put the square root of T. And we have inversely, so in the denominator, the length of the string, L. Okay, that's our equation. Now we're going to need to find K for the first set of values. If the number of vibrations per second is 5, when the tension is 225, so under the square root I need to put 225, which works out to be a nice square root of 15, right? Well, it's 15 when you square root it. Then the denominator is going to be 0.06, the length of the string, or 0.60. And we're going to multiply by 0.6 and then divide by the square root of 225, which is divided by 15. And you should get K equals to 0.2. All right, now we're going to, suddenly that light looks brighter. Ooh. Turn that off for a minute. Now we're going to go over here and we're going to put in the value of K for K, which is 0.2, the square root of T, all divided by L. And now we take the second set of values, determine the number of vibrations. I'm looking for V, 0.2. Now I need for T, which is the tension. The tension is 196. And the length of the string is 0.70. So square root 196 multiplied by 0.2 and divide by 0.7. I wish I had one of the calculators here with me, but I don't have it handy to show you where the square root button is, but I think you'll find it. On this calculator, you type the square root button and then you put the number after it. So try that out. Make sure you know how to use your calculator, and you're going to get 4. 4 is vibrations, and we need to put the units. So let's look back up here and see what it says. The number of vibrations per second is 5. Then we just need to put 4 vibrations per second. And that will do it. All right. I will see you all soon in next class, and I hope everything's going well. Please remember to do your MyMathLab homework for this section and any other sections we have completed up until this point. Goodbye.